Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, welcome to chemistry class with chapter 13 S and P block elements. Today, today we will discuss about oxides, structure of carbon dioxide and monoxide, structure of carbon dioxide, structure of silicon dioxide, similarities among carbon and silicon. Silicon dioxide is hard solid while carbon dioxide is a gas, although they both belong to group 4 oxides. Acid-base behavior of the group 4 oxides. Carbon and silicon oxides, carbon and silicon dioxides, germanium, tin and lead oxides, their dioxides, and at the last there is an assignment for you people. Let us start our today's lecture. First of all, what are oxides? Oxides are basically binary compound of oxygen with a more electropositive element. These are called oxides. Group 4 have three types of oxides. Monoxides, these are MO type like carbon monoxide, silicon oxide, germanium oxide, SN and lead oxide. Dioxides are of MO2 type like carbon dioxide, SiO2 and etc. Then there is a special oxides like C3O2, Pb3O4, Pb2O and Pb2O3. Let us explain these oxides. First are oxides of carbon. Carbon shows two types of oxides, carbon dioxide and carbon monoxide. Here you can see that in carbon dioxide, carbon is making two double covalent bond with two oxygen atoms. Here carbon is sharing its four valence electrons with two oxygen atoms and it is making two double covalent bonds. In carbon monoxide, it is carbon have 4 electrons, 1, 2, 3 and 4. Oxygen have 6 electrons in its valence shell, 2, 3, 4, 5 and 6. Its structure is carbon monoxide have a coordinate covalent bond in its structure. How? Basically, a lone pair of oxygen atom plays a vital role. Oxygen donates its lone pair to carbon and made a coordinate covalent bond. That coordinate covalent bond can be shown with the help of an arrow that originates from oxygen towards the carbon. Carbon dioxide have zero dipole moment while carbon monoxide have a specific value of dipole moment. Here is some difference between carbon monoxide and carbon dioxide. Carbon monoxide does not naturally occur in atmosphere while carbon dioxide is naturally occurring. Carbon monoxide produced as a result of incomplete combustion while carbon dioxide is produced during respiration of humans and animals, fermentation, chemical reactions, combustions of fossil fuels, woods, etc. Carbon monoxide is generated by gasoline engine without a catalytic converter, while gasoline engine with catalytic converter give carbon dioxide. Carbon monoxide is fatal poisoning, while carbon dioxide is rarely poison. Carbon monoxide is flammable, while carbon dioxide is non-flammable. Carbon monoxide, if increases in our atmosphere, it gives nausea, synops, nasal chest pain, and abdomen pain. While carbon dioxide gives sweating, increased heart rate, frostbite, convulsions, panic and memory problems. Carbon monoxide target major organs like lungs, blood, and central nervous system, while carbon dioxide target respiratory system. The next is structure of carbon dioxide and silicon dioxide. There is an enormous difference between the physical properties of carbon dioxide and silicon dioxide, which is also known as silicon 4 oxide or silica. Carbon dioxide is gas, while silicon dioxide is hard, high melting solid. Other dioxides of the group 4 are also solids. This difference that carbon dioxide is gas while silicon dioxide is hard, high melting solids. It can be because of the following reasons. Here is a structure of silicon dioxide, and you can see that this is a silicon atom and it is surrounded by four oxygen atoms. These four oxygen atoms make a single covalent bond with silicon atoms, and then it gives rise to a joint covalent structure. In this way, each silicon atom, when it's made four covalent bonds with four oxygen atoms, they give rise to a giant covalent structure. Structure of carbon dioxide. The fact that carbon dioxide is a gas means it must consist of a simple molecule. It is a triatomic molecules, means it consists of three atoms, one carbon and two oxygen atoms. Carbon form two double bonds with each oxygen atom. Carbon is sp hybridized and oxygen is sp3 hybridized. Carbon dioxide is linear and dipole moment is zero. Solid carbon dioxide has a face-centered cubic structure. Bond length between carbon and oxygen have value 115 cm. All three atoms have completed their octet, so the molecule of carbon dioxide is stable. Next is silicon dioxide. Structure of silicon dioxide is a giant macromolecular structure in which each silicon atom is covalently bonded with four oxygen atoms, and it gives rise to a giant covalent macromolecular structure. Basically, a tetrahedral unit is basic unit. In cristobalite, these units are joined as in diamond. This is the structure of cristobalite in which resembles with diamond. In quartz and tridymite, they are arranged spirally around the axis. This is the structure of quartz and this is tridymite, and you can see its structure. Similarities between carbon and silicon. These both belongs to fourth group. They both have four valence electrons and both can form four covalent bonds. Silicon dioxide is hard solid while carbon dioxide is gas. It is because silicon atom is larger in size than carbon. As you know that carbon is the top member and then silicon is at the after carbon. So its size is greater than carbon. And silicon, because of its greater size, tends to surround more oxygen atoms. Silicon forms single bonds with four oxygen atoms, while carbon forms two double bonds. Carbon forms a linear molecule of carbon dioxide with two oxygen atoms, while silicon atoms form four, four single covalent bonds and it is produced with four oxygen atoms. Because of this, it gives rise to a tetrahedral structure. The simplest formula of silica is SiO2, while whole crystal of silicon can be considered as one molecule. The next is acid-base behavior of the group 4 oxides. Oxides of the elements at the top of group 4 are acidic, while this acidic behavior of oxide decreases as you move down the group. It means bottom members are more basic in character, and some oxides of group 4 show amphoteric character, means they behave as they show both acidic and basic properties. The trend is therefore from acidic oxides at the top of the group towards amphoteric ones at the bottom and basic oxides at the center. Carbon and silicon oxides. We will study these oxides one by one. Carbon monoxide is treated as a normal oxide, but in actual it is very slightly acidic. How? It doesn't react with water, but it reacts with hot concentrated sodium hydroxide and form sodium methanoate. This is fact that it is a basic. It has a acidic character. Carbon monoxide has acidic character as it reacts with base. The next is carbon and silicon dioxides. These oxides are weakly acidic. As it reacts with water, it doesn't react with water because of difficulty of breaking of joint covalent structures, as we have previously read that silicon dioxide has a joint covalent structures and it is difficult to break its structure. Carbon dioxide reacts with water to a slight extent and produce hydrogen ion and hydrogen carbonate ions, that is HCO3. This is the reaction. Carbon dioxide reacts with water and gives proton plus HCO3, that is hydrogen carbonate ions. Solution of carbon dioxide in water is sometimes known as carbonic acid, but in fact it is only 0.1% of the carbon dioxide that actually reacts. So position of equilibrium is towards left hand side, that is towards reactant. With bases, carbon dioxide reacts with base, that is NaOH, and gives different products depending upon the reacting proportions. Like two molecules of NaOH react with carbon dioxide to gives you Na2CO3 plus H2O, while two NaOH react with carbon dioxide to gives NaHCO3. Silicon dioxide also reacts with sodium hydroxide, but only if hot and concentrated, and it gives rise to sodium silicate. In the same way, calcium oxide reacts with silica oxide to give calcium silicate. The next are germanium, tin, and lead oxides. First, we will study their monoxides. All these oxides are amphoteric, as these are the bottom members of the group 4, and they show both acidic and basic properties. First of all, we study the basic nature of monoxide. Its basic nature means they react with acid. They should react with acid to form salts. And here is the reaction. Monoxides of either germanium, tin, or lead react with HCl to give salt plus water. Here, this oxide, this monoxide is revealing its basic nature, as it is reacting with HCl. X may be germanium, tin, or lead. Lead chloride is fairly insoluble in water. Instead of getting a solution, it forms insoluble layer. Here, lead oxide reacts with HCl and form lead chloride plus water. But here, solution, acid solution should be concentrated once. Larger concentration of chloride ions give PbCl4 minus 1, that is complex soluble complexes with formula. Lead tetrachlorides are produced. Here it is 2Cl minus 1, 2Cl minus 1. These are chloride ions. Minus sign is misprinted, so please correct it. Now come towards the acidic nature of the oxides. All these acidic oxides react with base like sodium hydroxide to give water and its dioxides. Like lead oxide react to give PbO2 minus 2, that is plumbate 2 ions. Here, these oxides show their acidic character as it is reacting with base. The next are dioxides. Dioxides are also amphoteric in nature, that is, showing both acidic and basic behavior. First, we will study the basic nature of dioxides. Dioxides react with concentrated hydrochloric acids to give the compounds like HCl4. These are the salts. These dioxides are reacting with HCl. It means these dioxides are basic in nature. In higher concentration, in presence of water and chloride ions, they give a complex ion solution, that is HCl6 minus 2. Like 4 oxides, reaction should be done with ice cold hydrochloric acid. If the reaction is done with warmer, the lead 4 chloride decomposes and form lead 2 chloride and chlorine gas. It is because of its oxidation state being plus 2 rather than plus 4. This salt will break down, releasing HCl4 and chlorine gas. Acidic nature of dioxides. Dioxides react with hot concentrated sodium hydroxide and give soluble complexes to form XOH6 with minus 2 charge. Here is the reaction. Dioxides react with base in presence of water and that soluble complexes produced with minus 2 charge. This reaction show that these dioxides are acidic in nature. Similarly, PbO2 react with NaOH to give a more complex compound Na2PbO3 plus water. I hope you have enjoyed today's lecture. Here is an assignment for you people. Explain structure of carbon dioxide and carbon monoxide. SiO2 is hard solid while carbon dioxide is gas. Why? Carbon monoxide is acidic in nature. Justify the statement. Lead monoxides are amphoteric in nature. Give reactions. Discuss reactivity of silicon dioxides with help of reactions. Thank you and have a nice day.